Types of network models. Some standard network models are needed to enable communication between different kinds of networks effectively and efficiently. The two popular standard network models are OSI reference model and the TCP/IP reference model. The OSI reference model defines a 7-layer network and the TCP/IP reference model represents a 4-layer network. The OSI model dominated networking literature before 1990. The protocols related to the OSI model are not used anymore, but the model itself is actually quite conventional and still valid. TCP/IP became the dominant commercial architecture because it was used and tested extensively on the internet. The OSI reference model was never fully implemented. Unlike OSI reference model, in TCP/IP, protocols are widely used, but the model itself is not of much use. For the same reason, we have to examine both of them in detail. It is tough to explain some types of communication with TCP/IP, such as Bluetooth, etc., because TCP/IP is protocol dependent to both TCP and IP. But OSI model can explain them as it is protocol independent. OSI model. The International Organization for Standards, or ISO, is a multinational body dedicated to worldwide agreement on international standards. The OSI model is developed by the ISO in 1984 as the first step towards international standardization of the protocols, and it was revised in 1995. The OSI model is called Open Systems Interconnection Model because it deals with connecting open systems, that is, the systems that are open for communication with other systems. The purpose of the OSI model is to facilitate communication between different machines without making changes to the underlying software and hardware. The OSI model is composed of 7 ordered layers that allow us to think about a networking problem layer-wise. And they are application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Here, we can see the layers involved when a message is sent from sender to receiver. As the message travels from sender to receiver, it may pass through many intermediate nodes. These intermediate nodes usually involve only with the first 3 layers of the OSI model, because the other 4 layers are dealt within the sender and receiver. Data passing through the stack from application layer to physical layer is called encapsulation, and the reverse process is called decapsulation. Organization of OSI layers. These 7 layers can be divided into 3 groups based on their behavior. Physical, data link, and network layers can be thought of as network support layers. These layers deal with the physical aspects of moving the data from host to host, such as electrical signals, physical connections, physical addressing, reliability, transport, etc. Session, presentation, and application layers are the user support layers, and these layers support interoperability among different software systems in a host computer. Layer 4, or the transport layer, acts as a bridge between user support layers and network support layers, and it also ensures the transmitted data from network support layers must be in a form the user support layers can use and vice versa. Hosts and subnets are the basic elements in computer networks. Subnet is involved in lower layers 1, 2, and 3. Hosts are involved in upper layers 4, 5, 6, and 7. We can say that the upper layers are almost always implemented in software, and the lower layers are a combination of both software and hardware, except for the physical layer, which is mostly hardware. An electromagnetic signal at physical layer transmitted to the receiving device. At the receiving machine, the signal gets passed to layer 1 and is transformed back into digital form. Then the digital message is unwrapped layer by layer, with each layer receiving and removing the headers from physical to application layer. Finally, by the time it reaches the application layer, the message is converted back to the readable form. Let's explore each layer in detail.